Okay, so this is section 3.1, going over distributive law. So let's do a little deep dive into what the distributive law is. So this property is an algebraic property that connects addition and multiplication, okay? And it states that, let's say you have A, B, and C. So I'm going to do an example here. A, B, plus C. Well, what's going to happen is you're going to multiply the number by that sum. So our sum here is our A. And then we're going to distribute the multiplication to each of the other terms inside the parentheses. So that means I'm going to distribute the A into here and into the B and the C. So you're multiplying A times B, and then you're also multiplying A times C. This is going back to actually the first section of the textbook. So let's do an example of this problem. Oh, and before I do that, so when we multiply them, it's going to become A times B plus A times C. So that's how it'll be written once we distribute. So this is distributing. So let's do an example. So let's say my A is 2, my B is 3, my C is 4. So let's do 2, 3 plus 4. So we distribute. So 2 times 3 plus 2 times 4. So 2 times 3 is 6, and 2 times 4 is 8. So that means we get 14. So this is just a basic setup of distributing. So now let's go to a couple examples that are a little bit more complex than this one. Let's do one that's more similar to the last section that we did. So let's say I have x to the 5 over 4 equals 32. So what can I do? Well, the thing that I always know that I can do is I want to simplify the 32. So if I do 2 to the 5th, I know that equals 32. So I'm going to rewrite this again. And then I want to get x on the left by itself. And one of the rules we can use is to multiply by the reciprocal exponent. So reciprocal means I'm going to take the 5 over 4 and I'm going to multiply it by the opposite of itself, 4 over 5. And when I do that, I can also do the same to the other side. So these go away, that makes the x, so what's left. And then we do what we did in the last problems is 5 times 4 over 5. And what we get is 2 to the 4th. Because 5 times 4 over 5 is 4. 2 to the 4th gives me 16. So if you see the problem like this in your homework, this is how you would do it. But let's go more into problems that are more similar to distributed power. So let's do this one, 2a to the 1/2. And you'll actually recognize this from the work that we were doing in class, from the worksheet that I gave you guys. So let's distribute this. So that means I'm going to get 2a to the 1/2 times, this picture is a 1 in front, 1a. And then plus I get 2a to the 1/2 times -1, because I'm pretty sure there's a 1 in front of that, a to the 1/2. So now what do I do? Okay, so let's do the first one. So 2 times 1, so 2 times the 1 is going to give me 2. So and we have the same a, so this is going to be 2a to the 1/2. That's going to stay the same. Plus What about 2 times 1? Well, 2 times negative 1 is going to give me negative 2. So it's going to be negative 2. So 2 times negative 1. The a is going to stay the same because they both have a. And then what about my 1/2? Well, if we're multiplying exponents, what's the rule we use? This is going back to, I think it's property 1 in our properties of exponents. So that would be 1/2 plus 1/2. So we know that's going to 1/2 plus 1/2 gives me 1. So that's just going to be a to the 1. So I don't have to worry about that. I'm going to write it without a 1 there. So it's going to be 2a to the 1/2 plus minus 2a, or 2a to the 1. Now, I just have to write this in the correct form. Since we have a plus, we actually have a minus here, so that how I'm going to rewrite that is to incorporate that sign that's run out of 2a. So that's how you would do this problem. So let's do another one. This one's going to be a little bit more complex, but it's going to use the same method that we just used. So 1/2 y to the negative 1/3 y to the 2/3 plus 3y to the negative 5/6. So again, I'm going to distribute everything that's on the left-hand side into our parentheses. So what's going to happen, so I'm going to get 1/2 y to the negative 1/3 times y to the 2/3 plus 1/2 y to the negative 1/3 times 3y to the negative 5/6. Okay, so I look at my left-hand side first. I know that my 1/2, this is just 1, so 1/2 times 1 is going to be 1/2. So it's going to be 1/2 y. And then what about my exponents? Well, if I'm multiplying, we use rule 1 again, and we add our exponents. So negative 1/3 plus 2/3. Now what about the next area? So I have 1/2 times 3. 1/2 times 3 is going to give me 3/2. The y is going to stay the same because we have both y's here, right? Like the last one. And then the same thing again, I have 2 exponents that I'm multiplying. I will add those together. So now our next step is to add our exponents together, right? So let's do the first one. So I know that 1/2 y will be the same. And then in my calculator, when I do negative 1/3 plus 2/3, I get a positive 1/3. What about for the second one? When I do negative 1/3 plus negative 5/6, I get a negative 7/6. Remember, this is negative 7/6, and this is 1/3. Okay, so our next step is to figure out, okay, how am I going to write this? Because remember, if we have a negative, we have to write it in a fractional form. So this one definitely has to be written in fractional. And we want them both to follow that path, because you see both of these are also fractions. So we have to write them in a fractional form anyways. So how would I write the first one? So it would be 1/2, right? But where is the y to the 1/3 going to be? Is it negative? No, so it's going to want to hang out on top. So y to the 1/3. If it's not negative, it's going to stay up there. What about the second one? 3/2. This one's negative. So where's it going to want to go? It's going to want to go to the bottom. And this would be our answer. So if it's positive like this one, it wants to stay on top. If it's negative like that, it's going to want to go to the bottom. Okay, let's do one more. This one's gonna be a little bit more in depth because we're gonna have 4 different ones this time and not just 2. You'll see once I show it. Okay, so let's use the distributive law on this one. Okay, so I do this times this. So if you have 4, you always do the first one twice and the second one twice. So it'd be this one twice, and then this one second. So that means I did it 4 total times. So let's do this guy times this guy. So y to the 1/4 times 2y to the 1/4. Plus, we're going to do the same thing again. We're going to do y to the 1/4 times -1. Now we're going to do it again. So we're going to do 2 times 2y to the 1/4. And then the last one is 2 times -1. Okay. So now we can simplify. So if we're multiplying, like in the first one, that means our exponents have to add. So let's do the first one here. So what's going to happen is you're going to get 2 times 1, well that's 2y, because 2 times 1 is 2, 1/4 plus 1/4. Okay? So you simplified that one a little bit more. What about the second one? Okay, I have 1 times -1. Well, that's just going to be -1 minus 1y to the 1/4. Plus, 2 times 2 gives me 4, so it's going to be 4y to the 1/4. And then what about the last one? Well, 2 times -1 is -2. Okay, let's simplify the first one. So if I add 1/4 plus 1/4, say I'm adding a quarter with a quarter, that means I get half a pi. So I have half. 2y to the half. And then what about the next one? That's still going to stay -1. The next one, same thing again. So those are all simplified completely. So then what do? I just have to combine what I've solved. So it's just going to be 2y. But the next two I can actually combine. So -1 plus 4. Well, if I do that in my calculator, -1 plus 4, because I always have a hard time doing it in my head, is 3. So that means I'm going to get plus 3y. And then since I'm just adding exponents, you're just going to add it to, it's going to be 1/4. That's not going to change. It's not multiplication here. And then you write that as -2. So these you're not trying to solve per se, you're just trying to put it in the last final form. So that's how you solve for the distributive property.